Hello, everyone, and welcome to Fun Steps Academy. Today, we will talk about the 3 laws of Newton. Let's start with what is a force? A force is a push or pull that can start, stop, speed up, slow down, or change direction. Measured in newtons, N, forces always act between 2 objects. Types of forces: contact forces, applied force, friction, normal force, tension, air resistance. Non-contact forces: gravity, magnetic, electrostatic. Key ones: gravity, friction, air resistance, applied force. Balanced versus unbalanced forces. Balanced, equal and opposite, equal no change in motion. Unbalanced, unequal, equal causes movement, acceleration. Newton's 3 laws of motion. First law, inertia. Objects stay still or keep moving unless a force acts. More mass equals more resistance to change. Second law, force equals mass times acceleration. F equals ma. More force equals more acceleration. More mass equals less acceleration for same force. Third law, for every action there is an equal and opposite reaction. Forces always come in pairs: walking, rockets, swimming. Let's think of an example where all 3 laws are being applied for a comparison-based understanding. A rocket launch. Newton's first law, inertia. The rocket sits on the launch pad, at rest, and will remain there until an external force, thrust, is applied. Once in space, it continues to move at a constant velocity without needing to burn fuel unless acted upon by gravity or other forces. Newton's second law. The amount of thrust, or force, required depends on the mass of the rocket and how quickly it needs to accelerate. A more massive rocket requires greater thrust to achieve the same acceleration, which is crucial for determining fuel consumption. Newton's third law, action and reaction. The rocket engine pushes hot exhaust gases downward, action. As a direct reaction, the gases push the rocket upward with an equal force, reaction. Alrighty then, let's now have an MCQ quiz. 1. A 2-kilogram object accelerates at 8 meters per second squared. What is the net force acting on it? A. 4 newtons, B. 10 newtons, C. 16 newtons, D. 0.25 newton. Answer: C. F equals ma equals 2 times 8 equals 16 newtons. 2. A car traveling at 90 kilometers per hour brakes suddenly. A passenger lunges forward. Which law explains this? A. Newton's second law, F equals ma. B. Newton's third law, action and reaction. C. Newton's first law, inertia. Or D. The law of conservation of momentum. Answer: C. The passenger's inertia resists deceleration. First law. 3. A rocket ejects gases downward. What provides the upward thrust? A. Atmospheric pressure pushing upward. B. The reaction force from the ejected gases, Newton's third law. C. Gravity being reversed by engine heat. Or D. Newton's second law only. Answer: B. Finally, it is time for the fun fact of the video. Did you know, by Einstein's theory of general relativity, for every spacecraft ever launched, every satellite ever orbited, every planet ever visited by a probe, Newton's 3 laws, written by a 44-year-old mathematician more than 3 centuries ago, were sufficient? Thank you so much for tuning in. Don't forget to like and subscribe to Fun Steps Academy.